Okay, in this lesson we are looking at how to solve linear inequalities in one variable. Okay, instead of having is equal to, we are going to have is less than, is greater than, is less than or equal to, is greater than or equal to. Is less than, is greater than, is less than or equal to, is greater than or equal to. Those are the inequalities. The really nice thing is that these are solved exactly the same way as equations. I'm trying to get the variable all by itself. So in my first example, in order to solve for x, I subtract 5 on both sides. My answer is x is less than 3. So I don't get a specific answer, I get a description. Any number less than 3 would be a solution to that inequality. Number 2, x minus 4 is greater than or equal to negative 6. Add 4 to both sides. I get x is greater than or equal to negative 2. In number 3, divide both sides by 3 to get x by itself. We get x is less than or equal to negative 6. In number 4, I have x divided by 4 is less than or equal to negative 2. I have to multiply both sides by 4. The 4's cancel on the left. I get x is less than or equal to negative 8. In number 5, there's a two-step process because I have to get rid of two numbers. Add 1 to both sides. We get 2x is greater than negative 6, and then divide by 2. The final answer is x is greater than negative 3. In number 6, 5x minus 4 is less than 3x plus 10. I have x's on both sides of the inequality. I'm going to subtract 3x on both sides. I get 2x minus 4 is less than 10. Add 4 to both sides. 2x is less than 14. And divide by 2. X is less than 7. In number 10, again, I have variables on both sides. To get x by itself, I'm going to move one. And to avoid negatives, I'm going to move the smaller one, which in this case is negative 10x. I get 5 is greater than or equal to 8x minus 11. Add 11 on both sides to get x by itself. 16 is greater than or equal to 8x. And the last step, divide by 8 to get x by itself. I have 2 is greater than or equal to x. Now this is where some people have problems with the inequalities, especially when we get to the part on graphing. 2 is greater than or equal to x is the same thing as x is less than or equal to 2. Notice how the inequality in purple points to the x. If I move x to the other side, my inequality still has to point to the x. So if 2 is bigger than or equal to x, that says the same thing as x is less than or equal to 2. Writing it with a variable on the left will make it easier to graph. I'll repeat that when we get to the graphing. All right, number 8. This inequality is longer yet. I'm going to distribute first. 5x plus 6x plus 8 is less than or equal to, nothing I can do on the right, so I'm just going to write it down. Combine like terms on the left. 11x plus 8 is less than or equal to 4x minus 6. Now I have everything simplified, but I have x's on both sides. I'm going to subtract, I'm going to subtract 4x on both sides because it's smaller than 11. And since I'm running out of room, I'm going to do the other step at the same time. Since my variable is going to be on the left, I want my number to be on the right, so I'm going to move the 8. My new equation is 7x is less than or equal to negative 14 divided by 7. X is less than or equal to negative 2. Okay, so in all of these examples, all 8, we were getting x all by itself, just like we did when we did equations. Okay, now on the top, I said these are solved exactly the same way. Well, here's an exception. When you need to, let me do this in a different color. Let me do this in red. When you need to multiply or divide both sides of an inequality by a negative number, the inequality must change direction. For example, if I were solving the inequality negative 2x is less than 12, we need to divide both sides by, let me do this in a different color, negative 2. Negative 2x is less than 12. If I divide both sides by negative 2, the number I'm dividing by is negative. I get x, and I have negative 6, but less than has to change direction to greater than. Since we divided by negative 2, is less than changed to is greater than. This is the only exception. So if I have x divided by negative 5 is greater than or equal to 3, I need to multiply. Let me write this a little bit bigger. I need to multiply both sides by negative 5. The negative 5's cancel on the left. I have x and I have negative 15. But since this number was negative, when I multiply or divide by a negative, I have to switch the inequality. Second problem, 2x minus 5x is less than negative 15. Well, these are like terms. Negative 3x is less than negative 15. To solve, I have to divide by negative 3. They cancel on the left, so I have x. Negative 15 divided by negative 3 is 5. Inequality switches from less than to greater than. Okay. All right. Now we're going to talk about graphing. Okay. Our answer represents more than one number. Sometimes a visual representation is used. The number line is used for inequalities. The answers for is less than or is greater than do not include the number. By that, here's an example. X is less than 5 means all numbers less than 5, but not 5 itself. So I could have 4.9999. That would be a solution, but 5 would not be a solution. X is greater than negative 9 means all numbers greater than 9 but not, greater than negative 9 but not negative 9 itself. To show this on a number line, we can use open circles or parentheses. So X is less than 5. On a number line, I would have wherever 5 is, I would put an open circle, and less than would be this direction. Or if I used the parentheses, I would be at the number 5, and my parentheses would go towards the left because that's the direction I was going. If my answer was X is greater than 5 and I was going to use parentheses, then my parentheses, since I'm going to go in this direction, would curve to the right. I don't care which one you use. I'm used to the open circle, so it's usually what I default to. Okay, so if we have greater than or equal to or less than equal to, they do include the number. So X is less than or equal to negative 2 means negative 2 and all numbers less than negative 2. So negative 2 can be the answer. So if I were to graph that, I would use a closed circle to indicate I'm using that point. Instead of parentheses, it would be a bracket, which is the square. Actually, I've got the bracket drawn right there. Okay, so if I were to graph X is less than 1 on this graph on the left, I find 1. Less than is not 1, so I'm going to put an open circle, and I'm going to go left because it's less than. If I were using parentheses, it would be a left-facing parenthesis and an arrow. Okay, X is greater than or equal to negative 3. I find negative 3 on the graph. Since it has the equal sign, it will include that, so that would be a closed circle, greater than. If I were to use the brackets, it would be the square brackets pointing greater than. Okay, we're going to get our answers from our previous work, and we're going to put these on a number line. So the first thing I'm going to do is go get my answers. Number 1 was X is less than 3. Number 2 was X is greater than or equal to negative 2. Okay, so my first answer, I find 3, which is right here. It does not have the equal sign, so that's going to be an open circle, and less than is to the left. Or it would be a parenthesis to the left. In number 2, X is greater than or equal to negative 2. I find negative 2. Since it has the equal to sign, this would be a closed circle. And greater than means to the right. Or I would use a bracket to the right. Okay. Number 3, the solution was X is less than or equal to negative 6. Number 4, X is less than or equal to negative 8. Number 5, X is greater than negative 3. Number 6, X less than 7. Okay, so number 3. It has the equal sign, so this would be a closed circle at -6. But it says less than, so less than is going this way. Or I would have a bracket facing to the left. Number 4, x is less than or equal to -8. Again, this has an equal sign, so this will be a closed circle at -8, going less than, which would be to the left. Number 5, x is greater than -3. I find -3. It doesn't have the equal to, so it's going to be an open circle. Greater than is to the right. If I'm going to use the parentheses, I would curve the parentheses to the right. X is less than 7. Find 7. There's no equal to, so this would be an open circle. Less than is to the left, or it would be a curved parenthesis to the left. Now I thought I had this one on this example. Let's go back and get that problem. Remember when we had the answer 2 is greater than or equal to x? So 2 is greater than or equal to x. If I have a number line, two is my endpoint, and it has an equal to, and that would be a closed circle. Now, 2 is bigger than x. A lot of times I get students go, oh, that's greater than, so I have to go this way. But that's saying that my answers are here. Anything here is an answer. Well, let me pick a number. Let's say 10. 10 is on this line. If I put 10 here, is 2 greater than or equal to 10? No, it's not. So 2 is bigger than or equal to x is the same thing as x is less than or equal to 2. My closed circle is correct, but it would be going in this direction. Oops. Okay, that is one reason why when you did equations, you might have been taught to always put x on the left. It's easier to graph when you have an inequality instead of an equation. All right, we'll do this section on utilizing your calculator. So again, this is just making sure that you can use that tool. There are no rounding instructions, so don't worry about rounding. If you have a fraction key on your calculator, you can use that to enter fractions. If you don't have a fraction key, you would have to write it as 15.246 plus parentheses 3 divided by 8 parentheses times 7.24. Okay. The next one is negative 6.5262. Oh, there we go. The next one is negative 32.84225. Negative 32.8 if you're rounding it to nearest tenth. The next one $2.93. Okay, the next section. Give logical reasoning explaining what is wrong with the procedure used in solving each of the following inequalities. So here's the procedure, and you're told there is something wrong with that procedure. What is it? Okay, if I am solving this inequality, I would divide by -6. Okay, they divide by -6. That's good. -6x divided by -6 is x. 18 divided by -6 is, that should be a -3. And when you divide by a negative, the inequality should change direction. The greater than should change to less than because we divided both sides by a negative number. Also, 18 divided by -6 is -3, not +3. Second example, 8x is greater than or equal to -40. I would divide both sides by 8. I get x and -5, and they have is less than or equal to. The inequality switched directions, but what we divided by was +8, so it should not have changed directions. The inequality should stay as greater than or equal to because we divided by a positive number, not a negative. It doesn't matter that the number that we divided by was negative. It's whatever we divide by or multiply by. Okay, these next graphs didn't transpose to this document as well as I had hoped, but give logical reasoning explaining what is wrong with each of the following graphs. Okay, the solution is in red. X is less than 4. So this what it should have been right here on 4. It is incorrect because it shouldn't be a closed circle, it should be an open circle. My inequality is less than. A closed circle would be less than or equal to. Oh, number 4's graph is on the next page. What does it look like? No, that's okay. I don't like the picture anyway. Well, I guess I'll just put number 4 over here. It's less than or equal to 3. Okay, well first the circle is at 4.5. So first it has the wrong end point, and I think that's just because when it got moved over, the chart moved. But it should also be a closed circle. So I should have a closed circle at 3, If x is less than that, that would be to the left. So the direction of the arrow is correct, but the circle was in the wrong place and it should have been closed instead of open. Okay, continuing. Explain how you would solve. Add 3 to both sides. Then the 3's gone. Then I would divide by -8, which means the less than switches to greater than. In problem number 2, I'm solving for x, so I'm going to subtract 3 on both sides, which means the 3 will be gone, and then I'm going to divide both sides by 4. I don't switch the inequality because it's a +4, not a -4. In number 3, I have 2 x's, and they're on opposite sides. So I am going to add 4x to both sides. Now you might need to do that to see what to do next. The next step would be subtract 11 on both sides. And then divide both sides by 2. So now I get -8 is less than x. If you can graph with the x being on the right-hand side, you don't have to do any more work. If this is hard for you to graph, you want to rewrite, rewrite with x on the left to make it easier to graph. So if I move that, this would have x. It opens to x, or points to -8. So it opens to x and points to -8. All right. The last part of this lesson is going to be doing problem solving and then graphing my answer. So 6x minus 4 is less than 14. Add 4. And divide by 6. X is less than 3. To graph that, 3 is my endpoint. It's less than, so it's an open circle. Less than goes to the left. If you like parentheses, this would be a curve to the left above 3, and then drawing your line. Okay, number 2. 4x plus 2 is less than 22. Subtract 2 on both sides. Negative 4x is less than 20. Divide both sides by -4. Don't forget, when I divide by a negative, I'm going to have x on the left, because -4's cancel. My inequality has to switch from less than to greater than, -5. So I'm going to have a closed circle I'm sorry, an open circle above -5. Greater than is to the right. If you like parentheses, it would be a parenthesis curved to the right. Number 3, add 2 to both sides to get x by itself. I get 10x, the 2 cancels, is greater than or equal to -40. Divide both sides by 10. 10's cancel, I get x. I do not switch the inequality because I divided by 10. It doesn't matter that the other side was a -40 divided by 10. The number I divided by, that number, 10, is positive. So 10 is greater than or equal to -4. So in graphing that, I have this equal to, so I'm going to have a closed circle above -4 pointing to the right. If you like the brackets, it would be a bracket opening to the right. Number 4, I have x's on both sides. -6 is smaller, so I'm going to add 6x to both sides. I get -2 is less than 3x minus 20. Add 20 to both sides. 18 is less than 3x. Divide both sides by 3. I get 6 is less than x. So I know my endpoint is at 6 and it's an open circle. If 6 is smaller than my answers, that means all my answers should be in this direction. If it helps you to rewrite this, 6 is less than x means x is bigger than 6. This is easier to graph because greater than goes bigger. People seem to understand that easier, but it only works that way when x is on the left side. If you like parentheses instead of open circles, that would be a curved parenthesis to the right. Okay, number 5, the first thing I'm going to do is distribute. X plus 3x plus 6 is less than or equal to 6x plus 8. Combine like terms. 4x plus 6 is less than or equal to 6x plus 8. I have x's on both sides. I am going to subtract the 4x, which cancels it. I'm going to have x's on the right, so I'm going to move the 8. I have -2 is less than or equal to 2x, the 8's cancel. Divide both sides by 2. -1 is less than or equal to x. I did not divide by a negative, so my inequality stays the way it is. But if I want to graph that, I can put x on the left and -1 on the right, but the inequality pointed at -1, it still has to point at -1. If x is on the left, this is easier to graph. My endpoint is -1, so I'm going to have a closed circle above -1 because it has the equal to sign. Greater than is to the right. If you like brackets, it would be a bracket pointing to the right. Next example. First thing I'm going to do is distribute. 3x plus 4x minus 8 is greater than or equal to negative x minus 24. I can combine like terms. 3x plus 4x is 7x minus 8 is greater than or equal to negative x minus 24. I have x's on both sides. I am going to move the smaller. So I'm going to add x to both sides. I get 8x minus 8 is greater than or equal to negative 24. Add 8 to both sides. I get 8x is greater than or equal to negative 16. Divide both sides by 8. I have x is greater than or equal to negative 2. I divided by a positive 8, so my inequality didn't change. X is on the left, so this is easy to graph. I find negative 2. Since it has this equal to symbol, I'm going to have a closed circle, and greater 2 goes to the right. If you like the bracket, it would be a bracket opening to the right. Okay, word problem or two. Linda can spend no more than $25 in 2 days. If she spends $5 less in the first day than twice what she spends on the second day, how much can she spend each day? So I have 2 days. So I'm going to have no more than means she can spend up to 25, but not more than. So whatever she spends has to be less than or equal to $25. Okay. First day is being compared to the second day. So the second day is X. $5 less than twice what she spends. So $5 less is take away 5, and twice is 2 times. So my equation is what she spends both days, 2x minus 5 plus x. I can combine my like terms. 3x minus 5 is less than or equal to 25. Add 5 to both sides. 3x is less than or equal to 30. Divide by 3. X is less than or equal to 10. Okay? Less than or equal to $10 the second day. And less than or equal to 2 times 10 minus 5 would be less than or equal to 20 minus 5, $20. That's not going to work. Because that would give me, let me finish this. If I have that, 20 and 10 is 30. So that can't be right. $5 less in the first day than twice what she spends in the second day. All right, we're going to go to the next one. I'm going to come back to that one. I want to finish this recording and I'll fix that one later. A student has to earn a total of at least 292 points on, this should say 4 tests, in his math class to pass the class. And his total on the first 3 tests is 199. Set up an inequality necessary to find the minimum number of points he must earn on the 4th test to pass the class. Okay, so it's all tests has to be greater than or equal to 292. Total at least. So at least means 292 or bigger. His first 3 tests are 199 plus, I'll use F for my 4th test, has to be bigger than or equal to 292 points. So I need to figure out how much he needs to make on that test. Well, I solve that by subtracting 199. F is bigger than or equal to 93 points. He must earn at least 93 points. Another way to say that is 93 or higher. Okay, that'll be the end of this recording. I'll fix that problem and do a short one in a minute.